Now this reaction cannot be a Reimer-Tiemann. The reason behind it is that Reimer-Tiemann reaction basically is carried out with the alcohol, with the phenol, whereas the carbylamine reaction is being carried out with the primary amine. And if it is a primary amine, that means that amine will be having a NH2 group, that is a nitrogen atom. So therefore the organic compound will be a primary amine first of all, and second thing is that, which is given in the question, you are reacting this primary amine with the aqueous HCl and NaNO2 solution. Now the first point which you have made out is basically that compound gives full odor with CHCl3 and alcoholic KOH, therefore it is a primary amine. And if it is a primary amine, then the basic structure of amine will be RNH2. And the second point which we have made out is basically that this reaction will be a carbylamine reaction. But in this question, the point which is important to note over here is that we are not given either the molecular formula of the compound or the you can say the molecular mass of the compound. But for that matter, what we have been given is basically some information also. The information given in the question is something like we have a 0.295 grams of a sample of organic compound, and another point important is that we have reacted this organic compound with HCl and NaNO2 at 0 degree Celsius, and that too under the STP conditions, which says that some odorless gas is being produced whose volume is basically 112 ml. Now what happens is that when you react 1 degree alcohol with HCl and NaNO2, what we get is the alcohol and nitrogen gas is being evolved. So if you react RNH2 with the HCl in the presence of NaNO2 at 0 degree Celsius, then the product formed will be ROH and N2. So now what it says that what we are getting is the 112 ml of N2 gas by a reaction of 0.295 grams of a sample of organic compound. So therefore, if you know that 112 ml is being produced by the reaction of 0.295 grams, then 22400 ml of N2 will be produced by 0.295 multiplied by 22400 divided by 112, and that actually gives you 59 as the answer. And 59 is basically the amount of the organic compound which will release 22400 ml of nitrogen. So therefore, we have basically calculated the amount of the organic compound for 22400 volume. That means we have calculated the amount of the organic compound for 1 mole of the substance, or you can say for the 1 mole of the gas which is being liberated. So that means when you have calculated it for 1 mole, that means that we have calculated for the molecular mass. So therefore, the answer which we have obtained as 59, which we are claiming that this much amount of the organic compound is required for 22400 ml of nitrogen. So 59 is basically the molecular mass of the organic compound. Now if you know the molecular mass of the organic compound, that is 59, and we know that the structure of the amine will be RNH2, and this RNH2 is basically having a molecular mass as 59. So therefore, if you now in the RNH2, what you have is NH2 group as fixed. So therefore 14 of the nitrogen and 2 of the hydrogen atoms, you can say this we can subtract it from 59, and then we will get the molecular mass of the R group. So which actually will be 59 minus 14 plus 2, that will come out to 43. So therefore the R group in the amine should have a molecular mass equals to 43.